Now, some of these membrane proteins can act as receptors, where they, by binding given molecules, can signal the cell to do something. And so what it's going to do is it's going to receive that signal and initiate a response within the cell. Now, let's say that that signaling molecule, the only thing it can really do is bind to that receptor, but it can't go into the cell. Then what it's going to do is going to take that signal and convert it to a different type of signal. It's still a signal. But now it's going to convert it to a different type of signal and initiate a response within the cell. And that's where, and we'll use this term a few times, the terms transduction or to transduce. If you have something that is a transducer, it changes a signal from one type of energy to another type of energy. Like if I had a light that would blink at a given frequency, I can actually convert that to sound to match whatever that light frequency is, and vice versa. So transduction is to convert from one form of energy to another. So if I have one form of energy, a signaling molecule, that initiates a biochemical reaction within the cell, then I'm taking one signal and converting it to a different one. And so that's what we're referring to when we use a receptor protein that detects something going on outside and then change that to an intracellular signal. We're going to see this a great deal. Hormones are a great example. As our hormones bind to specific receptors, insulin, okay, is a hormone, regulates the amount of sugar that we take out of our bloodstream and into our cells. And it binds to specific insulin receptors so that the cell knows, oh, I'm supposed to do this because there's more insulin present. So we'll talk more about that as well. As we talked about the formation of proteins, the primary, secondary, tertiary, and even quaternary structure of proteins, one of the types of proteins we created were proteins that helped speed up or catalyze chemical reactions, and we called those enzymes. And we mentioned the fact that these enzymes are those that are going to decrease the amount of energy required for something to happen. So we can have an increased number of chemical reactions take place in the same amount of time. So we're not saying that the chemical reactions wouldn't have happened. We're just saying, really to facilitate how our body works, we had to speed those up. And so that's what enzymes do. And throughout this course, we'll be using a lot of examples of enzymes because our metabolic pathways are dictated by those. Now we have proteins that we refer to as linkers, and they are linker proteins because they can connect things that are intracellular with those things that are extracellular. They can also link structures that are neighbors to each other, so two extracellular structures. So we're just saying proteins, and we can get into detail on all sorts of names that help hold cells to an extracellular matrix or hold cells to another cell and things of that nature. Help link the cell membrane to the cytoskeleton, the skeleton of a cell that's on the inside, just like your skeleton is on the inside. So we'll look at a number of those examples here as we go along. Now, one of the big roles that membrane proteins also play is acting as cellular markers. And this is one of those things where we get into issues when we transfuse blood into a patient. We get into issues when we want to transplant tissues from one patient to another, where it's pretty tough to get a perfect match, because really the only couple times you could get a perfect match is if it was yourself. And so we do like skin grafts where we'll take it from one place on the body and put it into another. We also look at situations where we try and get the closest person we can match. Well, if you happen to have a person who to you is an identical twin, so you have an identical twin, then there's more likely to match. Okay, now it's still not a guarantee, because really your DNA was only identical the first time that split took place. And changes, your cells do not copy their DNA or replicate their DNA the same way every time. For the most part they do, but situations arise and errors exist. And so it's not a guarantee, even though you have an identical twin, that you are an exact match. Now, you're going to be a better match than someone who's not your identical twin, don't get me wrong. But there are some differences that arise as growth takes place and as cells divide and do some of those things. And so we're always a little bit different than the tissue we may be acquiring from someone else, whether it be blood, okay, which is considered a tissue, or whether it be an organ or other type of tissue. So we're not identical. Now, some people would say, well, wouldn't it be easier if everyone was the same blood type? Wouldn't it be easier if we didn't have to worry about typing tissue and typing blood and doing some of those things. Well, it would. But the issue becomes your body has to be able to recognize itself. And so in that situation, if your body doesn't know what you look like, so if you fail to recognize self, then your body doesn't know what foreign is. So it's like if you've never looked in a mirror, never saw your reflection, you'd assume you kind of looked like everybody else. And that may be a good thing, that may be a bad thing. But you can kind of get the idea there. Where if you've never seen yourself, you wouldn't recognize yourself. Okay? And so you wouldn't know what different really was. Well, the same thing is true of like our immune system. Where if our immune system doesn't look and say, oh, that's me, therefore I'm going to tolerate me. That's my stomach and my liver and my kidney and my skin and all my stuff. And so all of a sudden something shows up that's not mine, it's not yours, and your immune system looks at it and goes, okay, that doesn't have the right arrangement of molecules to be me, therefore it needs to go away. And so our recognition of self versus our recognition of foreign becomes important to us. And so these membrane proteins will fly like flags that says, hey, this is me, okay, versus some sort of invader is going to look different than that. And so hopefully that invader is disposed of before it has the opportunity to cause disease. And many of these molecules are referred to as glycoproteins. And it's because we have a carbohydrate chain attached to a protein. So that's where that compound word comes from. Glyco referring to the carbohydrate, and the protein referring to the membrane protein that we've been discussing. An example of these are, for example, I don't know if you've heard this term, but MHC molecules. MHC stands for Major Histocompatibility Complex. These are the molecules that we look at whenever we're transplanting tissue from one patient to another. So as just like they would blood type you to determine blood compatibility, well, they tissue type people as well to make sure, all right, if we're going to give that person this kidney, well, it better match at least as closely as possible. So they take that into account.